Hello students, so in this lecture video I am going to solve another method of numerical on a fin element. Okay, so far we solve the problems on 1D element, okay, of the fin and 2D element. Okay, so in this how if the fin is, if it is considered as a 2D element, it is a breakage here is the free end, then what is the okay, how we are going to solve that we are going to learn in this lecture video. Okay, so if you breakage, if the break takes place, okay, this is like this, okay, then the formula going to changes. Okay, that is a force due to convection at free end. Okay, so that formula we are going to use in this numericals. Okay, so look at here, I will read the question here. This is also very important. And okay, find the temperature distribution and the heat transfer through a iron fin. Okay, so this is the iron fin is there. Okay, so of the thickness 5 mm, so 5 mm thickness is there. Okay, so this is the 5 mm thickness, the height is given 50. Okay, so 5 mm thickness is there, the height of this is okay, so 50 mm, and the width is 1000. Okay, the width is 1000. Okay, that is height, thickness and the width, three dimensional. Okay, so width is given 1000 mm, the heat transfer coefficient around the fin is 10 watt per meter square. Okay, Kelvin. Okay, so this is they given what the heat transfer due to convection, H is given, and the ambient temperature, that is T infinity, is given 28 degrees centigrade. The base fin is 108 degrees centigrade, that is T1 is given base temperature. Okay, and take K is equal to thermal conductivity is equal to 50 watt per this is what 50 watt meter Kelvin. Okay, so use the two elements. Okay, look at this, this is a given question. Okay, the given diagram. Okay, so this is a what the that is a heat transfer here. This is the iron fin. Okay, thickness is given 5 mm, height is 50, and the width is 1000 mm. So heat transfer coefficient H is also given, and ambient temperature is also given, and the surface temperature is also given, thermal conductivity also given. Okay, consider is, they are telling consider it's a 2D elements. Okay, if you divide this exactly middle, so like this it will happen. The height of this is 50, total is 1000, so one is 50 mm. Okay, so this width is given, that is 5 mm, height is given 1000, and thickness is equal to 5 mm. Okay, so first step is note down the given data here. Okay, the given base temperature is equal to T1 is equal to 108 degrees centigrade. Okay, so they given 108, that is what where it goes 108. The base temperature is denoted by T1 or surface temperature. Okay, and the length L1 is equal to length, how much they given height. Okay, so height nothing but the what, the length L1 is equal to 50. So if you divide by this 50 by 2 means you are going to get it, if you convert this meter means 0.025 meter. Okay, so height okay, so thickness T is given, that is thickness is denoted by T, they given thickness 5 mm denoted by T, which is equal to 5 mm, convert into meter is equal to 0.05. Okay, so how to convert, divide by 1000. Okay, so height H is equal to given, so 50 mm. Okay, this height is given for this okay, so it is denoted by small h. Okay, so it capital H is there, small h is equal to 50 mm. Again you have to convert this into meter. Okay, ambient temperature is given, T infinity is equal to 28 degrees centigrade. Here they given ambient temperature. Okay, so ambient temperature is equal to 28 degrees centigrade, surrounding temperature they given, and thermal conductivity K is equal to they given 50 watt per meter Kelvin. Okay, so heat transfer coefficient H is equal to given, H is equal to what, 10 watt per meter square Kelvin given. So here, okay, so now we know the area for the this cross section. Okay, the rectangular section is equal to what, breadth into thickness. Okay, so area we need to calculate. Okay, area because it is there in the formula. Okay, so we required area, so how to calculate area? So in the previous problem they given diameter and radius. Okay, but here they given thickness and breadth. Okay, so area is equal to A1 is equal to B into T, so breadth is equal to they given 1000, so convert into meter means 1, and 0.05, so you are going to get 0.05 meter square. Okay, perimeter is equal to what, for the this rectangular cross section perimeter formula is P is equal to 2 plus 2 into B plus T. Okay, so substitute these values, you are going to get 2.01. Okay, so this is the given data, we have to note down from the given diagram or given in the, they will give given question clearly. Okay, so once if you note down the given data, so you have to remember the list of formulae first. Okay, that is heat due to conduction, heat due to convection. Okay, and force factor and equilibrium condition, apply the boundary condition. Okay, so then you can get the answer. Okay, the first step is what, convert the given diagram into the finite element model. Okay, so if you break this, okay, so here 1 2 3, node number 1 2 3, that is T1 T2 T3. Okay, so this is element number 1, this is element number 2, so L1 L2. Okay, so T1 is given, you need to find out the T2 and T3 value. Okay, so here there is no any rotation, displacement, vertical displacement, nothing. So T1 T2 T3 are the nodal temperature, they are flowing temperature around the fin. Okay, that T1 is already given initial temperature, so you need to calculate the T2 and T3. Okay, so now for the first element, okay, Kc is equal to, we have the formula for first element, okay, heat due to conduction is equal to what, A1 K1 L1 1 minus 1 1 minus 1 1. Okay, substitute all the values here, so you are going to get 10 minus 10 minus 10 10. Okay, you have to note down this is due to first element. Okay, stiffness matrix for the convection. Okay, so we have the heat due to convection, we have the formula is equal to what, Kh is equal to HPL1 62112. Okay, so substitute all data here, so you are going to get this 0.167 0.08375. Okay, so H is the here heat due to heat transfer, and P is the perimeter, L is the length. Okay, so now, so K1 is equal to what, heat due to conduction plus convection. Okay, so this is the difference in the what we solved in the previous problem. Okay, so in the previous problem you calculated separately, but here brackets takes, okay, 2D element. Okay, so now K1 plus K1 is equal to Kc plus Kh. Okay, so if you add these two, you are going to get 10.16 minus 9.91 minus 9.91 at 10.16. Okay, so this is for the first element. Okay, similarly you have to calculate the second element. Kc is equal to A2 K2 by L2 1 minus 1 minus 1 1. Okay, same what we calculated here, same you have to calculate heat due to conduction for the second element. So second A2 value you have to substitute here, you are going to get 10 minus 10 minus 10 10. Stiffness matrix for the convection is equal to length, you have to replace here L2, so you are going to get this. Okay, so since at node number 3 heat is lost due to the surrounding, okay, by the convection, okay, due to surrounding because it is exposed. Okay, at node number 3 is at node number 3 heat is exposing. Okay, it is not fixed here. Look at the diagram here in the boundary in here. So one end is fixed here, the at node number 2, at node number 3 is heat is exposing to the surrounding. Okay, so this condition is changed here. Okay, so in the previous problem what we solved here, something heat conduction convection is there. Okay, but here it completely exposing to the environment. Okay, so if such a case we have to use this formula. Okay, so at node number 3 heat is lost by the surrounding by convection because it is exposing. Okay, there is no any restriction there, it is not there any restriction in that point, node number 3. Okay, so because of that the formula we are going to use this formula, that is, so Kh at end is equal to Ha0001. Okay, so this is, if it is beginning statement, this one will come this side and which is here 0. Okay, so at the end we are going to use this formula, Kh due to convection is equal to end is equal to Ha0001. Okay, so H is nothing but the heat transfer area, so we know all these values, substitute here, you are going to get this. Okay, Kh is equal to end is nothing but Kh is nothing but heat that is what heat lost at the end side. Okay, so 0 comma 0 substitute means you are going to get this value. Okay, so now K2 is equal to was Kc plus Kh plus Kh. Okay, so that is this is Kc, this is heat due to conduction, this is exposing. Okay, okay, if you add those two you are going to get K2 value. Okay, 10.168 minus 9.9 minus 9.9 10.28. Okay, so I will repeat here, this is very important. So in the first element we don't have any problem. Okay, that is Kc plus Kh. Okay, that gives K1. Okay, heat due to conduction. Whereas in the second element here heat due to conduction convection plus heat is exposing to the surrounding, you have to consider all these three. Okay, so that is what here I wrote, heat due to conduction, this is convection. Okay, stiffness matrix for convection, and this is due to the what, heat loss to the surrounding, convection. Okay, that all these three value you have to add in this problem. Okay, that is K2 is equal to Kc plus Kh plus Kh, this is end surface. Okay, if you add all those, okay, you are going to, and here we are talking only the second element only, 1 2 1 2 1 2, you can add easily. Okay, so if you add those means you are going to get 10.16 minus 9.9 minus 9.9 and 10.21. Okay, so now we know the value of K1 and K2, therefore the global stiffness matrix is equal to what, according to the node number you have to write here 1 2 3, so this is 2 3, the previous one is one element is 1 2. Okay, if you like that previous how we added, so from the K1 and K2 if you add these values, so you are going to get 3 into 3 matrix, this is T1 T2 T3 here. Okay, so here T1 T2 T3, according to the node number you add, you are going to get this matrix. Okay, now force vector due to the free end convection. Okay, so after this we need to calculate the force vector. Okay, force vector due to end convection, we have the formula this. Okay, end surface we have the formula A H T infinity, that is 0 comma 1. Okay, area you know, heat transfer convection you know, ambient temperature you know. Okay, substituted in this, so you are going to get 0 1.4. Okay, so this is force due to force vector due to free end convection. Okay, free end convection very important for second element, you have to remember this. Okay, formula. Okay, so now global force vector equal, become 3 into 3 matrix, so write down here. So equilibrium condition is equal to what? K into T, which is equal to F. So K value substitute, nodal temperature value substitute, this is not equal, this is into, okay, F write down here. So okay, we know that the T1 value, okay, so after writing this, we have the boundary condition T1 value they given. T1 value is equal to 108 degrees centigrade, okay. So first you just to eliminate this, okay, so eliminate this, you have to multiply this minus 9 point second row, this column you are going to get this, okay. Again from the second row, third row, you have to multiply this, you are going to get this, okay. Now we know the value of T1 is equal to 108 degrees centigrade. This you substitute in this equation, so you are going to get this equation, okay. So now this replace the that is what the second equation with this 170, okay. So that if you replace that second row with the equation number 1, so you are going to get this equation. That means what? You have to replace this equation, okay. So this complete you have to replace to this, okay. So you are going to get, okay, T2 T3 value. On simplification you are going to get the T2 value and T3 value, okay. Like that you have to calculate the temperature distribution in a thin element, that is what the fin element, okay. So here what is the difference between previous problem and this problem? So here first element, so heat due to conduction and convection, okay. If you while considering the second element, it is due to conduction, convection plus heat is exposed to the surrounding, that also you have to consider here, okay. So that is the only change here in this problem, okay. Like that you have to solve the numerical problems on what the problems on fin element, okay. So this is very important, okay. Okay, I hope you understand this problem, okay. So just you have to remember the list of formula, that's it. Apart from the same procedure is there, okay. So I hope you understand this, okay. Thank you.